July 1st, 2025. Atlas telescope in Chile picks up a dot moving against the stars. Fast. Too fast. Within 24 hours, astronomers realize this thing isn't from here. It's the third visitor from beyond our solar system. They call it 3I Atlas. But here's the problem. Everything about this object screams impossible coincidence. Its path aligns perfectly with Earth's orbit within 5 degrees. It arrives at the exact moment to buzz Mars, Venus, and Jupiter. And it will hide behind the sun at perihelion where no Earth telescope can watch it. What are the odds of that trajectory? 1 in 2,000. What about the timing for planetary encounters? 5 in 1 million. When you roll dice that loaded, you start asking different questions. The mainstream story goes like this. 3I Atlas is an ancient comet, 7 to 14 billion years old, kicked out of some distant star system and wandering the galaxy until it stumbled into ours. Carbon dioxide rich, water ice poor, nothing to see here. But Avi Loeb from Harvard looked at the numbers and published papers with a different theory. What if this isn't a comet at all? What if it's designed to look like one? If you value documented space science like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. The script is researched and factual, using sources from NASA's official 3I Atlas mission page published July 3rd, 2025 by peer-reviewed papers in the Astrophysical Journal from August 2025, and Loeb's technical analysis published in Harvard-Smithsonian Center for Astrophysics, preprint HCL 25 from July 16, 2025. These aren't tabloid sources. These are the institutions tracking this object with billion-dollar telescopes. Now back to the information. On Discovery Day 3, I Atlas sat 4.5 astronomical units from the Sun. That's beyond Jupiter. At that distance, nothing should be bright enough to spot unless it's massive. Initial estimates said 20 kilometers wide. Then the Vera Rubin Observatory cut that to 10 kilometers. Hubble dropped it again to 5.6 kilometers maximum, maybe as small as 440 meters. But here's the catch. If you shrink the nucleus, you need something else making it bright, like engineered surfaces, or active systems. The James Webb Space Telescope trained its infrared eye on 3 Opportunity Atlas in August 2025 and found the highest carbon dioxide to water ratio ever recorded in any comet, 8:1. Most comets are water ice with traces of other stuff. This thing burns carbon dioxide like rocket fuel. The SphereX mission detected a carbon dioxide coma stretching 348,000 kilometers across. No jets, no tail structures, just a perfect sphere of gas. NASA says it's natural. They point to the coma, the outgassing, the dust particles. Classic comet behavior. But listen to what they're not saying. Where are the water jets that should dominate any comet this close to the sun? Why does it produce more carbon dioxide than H2O when solar heating should vaporize water first? And why is it moving at 137,000 miles per hour, twice the speed of the first interstellar visitor, Oumuamua? Here's where Loeb's analysis gets dangerous. He calculated that 3 Interstellar Atlas will pass behind the Sun on October 29th, 2025, at exactly the point where it could execute what's called a reverse Oberth maneuver. Picture this. You're flying a spacecraft at maximum speed. You fire engines at perihelion to slow down just enough to stay bound to the solar system. The Sun hides you from Earth telescopes during the burn. Perfect cover for changing course. The trajectory math is brutal. 3. I Atlas approaches Venus at 28 million kilometers on November 3rd, Mars at 18 million kilometers on October 2nd, Jupiter at 54 million kilometers on March 16th, 2026. Each encounter perfectly timed for gravitational assists or payload deployment. The orbital mechanics require precision that natural objects don't possess, but the real smoking gun might be the age. Analysis of its galactic velocity components puts 3I Atlas between 7.6 and 14 billion years old. That's older than Earth, older than our solar system. This thing has been drifting through space since before the planets formed, carrying ices that predate everything we know. What are the odds that such an ancient object arrives now, on this trajectory, at this moment in human history when we finally have telescopes powerful enough to see it coming? Consider the alternatives. Option 1. 3. I Atlas is a natural comet with impossible luck. It's somehow maintained structural integrity for billions of years in interstellar space. It's somehow acquired a carbon dioxide to water ratio unlike anything in our solar system. It somehow arrived on a retrograde trajectory aligned with the ecliptic plane to within 5 degrees. And it somehow timed its approach to encounter multiple planets during humanity's first century of serious space observation. Option 2, it's artificial. a probe from a civilization that mastered interstellar travel millions of years ago, designed to look natural, equipped with chemical propulsion systems that mimic cometary outgassing, programmed to survey planetary systems using gravitational assists and stealth maneuvers. The carbon dioxide isn't sublimation, it's exhaust. The perfect timing isn't coincidence, it's navigation. Loeb published his analysis with Adam Hibbard and Adam Crowell in July 2025. They don't claim certainty, but they lay out a testable hypothesis. If 3 I-Atlas changes velocity during perihelion passage, if it alters course by even tiny amounts, if it releases smaller objects near the planets, then we'll know. The problem is timing. Earth will be on the opposite side of the sun when 3 I-Atlas reaches perihelion. We'll be flying blind during the most critical 24 hours. NASA missions are scrambling to fill the gap. The Juno spacecraft orbiting Jupiter could observe 3 I-Atlas when it passes within 53.6 million kilometers. On March 16, 2026, Mars orbiters might catch glimpses during the October encounter. But the smoking gun moment, perihelion passage on October 29th, remains hidden behind our star. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter will attempt observations from their position near the red planet. These cameras are designed to photograph Martian terrain from hundreds of kilometers away, not track small objects 30 million kilometers distant. The comet will cover less than a pixel in their images, but even a pixel might show whether 3 I-Atlas behaves like expected. December brings the second chance. 3 I-Atlas will reappear from behind the sun on the outbound leg of its trajectory. If it's natural, it should be losing brightness as solar heating decreases. The carbon dioxide should freeze back onto the nucleus. The coma should shrink. But if it's artificial, if it used perihelion to change course, the post-solar observations will tell a different story. The public can track this in real time. Amateur astronomers with 8-inch telescopes could spot 3 I-Atlas when it emerges in late November 2025. Its magnitude should reach 11.5 at closest approach to Earth on December 19th. That's bright enough for serious backyard equipment. Citizen scientists submit observations to the Minor Planet Center database, creating a distributed monitoring network that governments can't control or censor. But consider the implications if Loeb is right. If 3 I-Atlas is artificial, then we're not alone. We're being watched, surveyed, possibly judged by intelligences that think in geological timescales and plan missions lasting billions of years. The dark forest theory suggests that revealing yourself in a hostile universe invites extinction. Advanced civilizations stay hidden for good reason. The trajectory analysis supports reconnaissance purposes. 3. I-Atlas will pass close enough to each major planet to deploy microsatellites or conduct detailed scans. Its retrograde orbit provides maximum exposure to different planetary faces as worlds rotate beneath it. The timing allows systematic surveys of Mars, Venus, and Jupiter during optimal positioning. This isn't random wandering, it's methodical exploration. Even the discovery circumstances fit the pattern. 3. I-Atlas emerged from the direction of Sagittarius, where the galactic center creates dense star fields that mask approaching objects. It remained hidden until July 1st, 2025, giving humanity minimal preparation time. If you wanted to study a civilization without triggering panic or defensive responses, this is exactly how you'd time the revelation. The carbon dioxide signature might be the tell. Natural comets from the outer solar system contain mostly water ice because that's what condenses in the cold regions where they form. But 3. I-Atlas formed somewhere else, under different conditions, possibly around a different type of star entirely. Or the carbon dioxide isn't natural at all. Chemical rocket engines burn hydrocarbons and produce CO2 as exhaust. What looks like comet outgassing could be propulsion system emissions. NASA maintains official silence about artificial possibilities while mobilizing every available telescope. The agency's position is clear. 3. I-Atlas poses no threat to Earth, maintains safe distances from all planets, and displays expected cometary behavior, but their actions suggest different priorities. Why deploy so many observation platforms for a routine interstellar comet? Why coordinate with European and Japanese space agencies for maximum coverage? Why focus instruments designed for other missions onto this single object? The answer might be timing. 3. I-Atlas represents the first interstellar visitor that humanity can study during both approach and departure phases. Oumuamua was discovered leaving the solar system. Borisov provided limited observation windows. But 3. I-Atlas gives us months of data collection across multiple wavelengths and observation platforms. If artificial intelligence wanted to reveal itself gradually, allowing human civilization to adjust without panic, this is the perfect scenario. December 19th, 2025. 3. Atlas reaches closest approach to Earth at 167 million kilometers. Close enough for detailed spectroscopy, far enough to prevent impact scenarios. The date marks humanity's best chance to determine the object's true nature using every telescope on the planet and in space. If patterns emerge that can't be explained by natural processes, if the object shows signs of course correction or payload deployment, if it responds to human radio signals or changes behavior when observed, then Loeb's hypothesis moves from speculation to confirmed contact. The stakes couldn't be higher. First contact with extraterrestrial intelligence would rewrite every assumption about humanity's place in the universe. But the implications cut deeper. If 3I Atlas is artificial, then its builders possess technology that renders human civilization defenseless. Interstellar travel, stealth capabilities, surveillance systems that operate for billions of years. If they wanted to eliminate us, we wouldn't see them coming. The object's age presents the most unsettling possibility. 14 billion years means it predates most stars in the galaxy, whatever civilization launched. 3I Atlas had time to colonize thousands of worlds, develop technologies beyond imagination, possibly transcend physical limitations entirely. We might be insects being studied by gods. But there's another interpretation. Maybe 3. Atlas represents a probe from humanity's own future. Time travel remains theoretical, but if causality permits closed loops, then our descendants might be studying their own origins. The perfect knowledge of planetary positions, the careful timing to avoid panic, the gradual revelation designed for maximum scientific benefit. These could be gifts from tomorrow's humans to today's scientists. The retrograde orbit supports this theory. Most objects in the solar system move in the same direction the planet's orbit. Retrograde motion requires specific insertion physics. Natural interstellar objects shouldn't preferentially choose retrograde trajectories aligned with the ecliptic plane. But time travelers would know exactly where to place their probe for optimal observation of early 21st century human civilization. On October 29, 2025, 3I Atlas vanishes behind the sun. For 40 days, no Earth-based telescope can track its position or behavior. It could change course, deploy secondary objects, rendezvous with hidden facilities, or simply continue on its predicted trajectory like any natural comet. When it emerges in December, of course, we'll know whether humanity just received first contact or witnessed an elaborate false alarm. The scientific community splits along predictable lines. Conservative astronomers maintain that extraordinary claims require extraordinary evidence, and no evidence yet proves artificial origin. But younger researchers, those who grew up expecting alien intelligence, approach 3I Atlas with different assumptions. They see the mathematical improbabilities, the perfect timing, the unique composition as signals rather than coincidences. Public reaction remains muted because most people don't understand the implications. A comet from another star system sounds interesting but not threatening. The media focuses on spectacular images from Hubble and Webb, rather than trajectory calculations and statistical analyses. But online communities dedicated to astrobiology and SETI research track every observation, every paper, every anomaly reported by professional astronomers. The betting markets hedge their predictions. Polymarket opened wagering on whether 3I Atlas proves artificial by December 31st, 2025. Early odds favored natural origin, but money flows toward the artificial hypothesis as more data emerges. Financial algorithms processing telescope data reach different conclusions than human astronomers reviewing the same evidence. If you value documented Viking and Norse era history like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This research comes from multiple peer-reviewed sources, including the Harvard-Smithsonian Center for Astrophysics preprint server, NASA's official mission documentation, and observational data from the European Southern Observatory's Very Large Telescope, published September 4th, 2025. Now back to the information. Amateur radio operators monitor frequencies around 3I Atlas for any electromagnetic emissions that might indicate artificial origin. The Search for Extraterrestrial Intelligence Institute coordinates listening campaigns during the object's closest approaches to Earth. So far, silence. But artificial intelligence advanced enough for interstellar travel might communicate through channels humans haven't discovered yet. The psychological impact grows as December approaches. Religious leaders prepare statements about humanity's relationship with cosmic intelligence. Military strategists game scenarios for contact with superior technology. Scientists debate disclosure protocols for confirming artificial origin. Even if 3I Atlas proves natural, the experience of considering alien visitors changes human perspective permanently. But the most disturbing possibility remains unspoken in official channels. What if 3I Atlas isn't the first artificial object to visit our solar system? What if similar probes have been conducting surveillance for centuries or millennia, hiding among asteroids, comets, and space debris? The technology to camouflage artificial objects as natural ones might be standard practice for advanced civilizations exploring the galaxy. Historical anomalies take on new significance. Unusual meteor showers, comets with strange orbits, objects that appeared and disappeared from astronomical records. The Great Comet of 1618 moved on a trajectory that brought it close to multiple planets. The Tunguska event of 1908 involved an object that exploded in atmosphere without leaving typical meteorite debris. Maybe humanity has been under observation longer than anyone imagines. December 19th approaches. The date when 3I Atlas makes its closest pass to Earth, becomes a focal point for scientific observation and public speculation. Will it behave like a natural comet losing velocity as it moves away from the sun? Or will course corrections, anomalous emissions, or unexpected behavior reveal artificial control systems? The answer determines whether humanity enters 2026 as a lonely species on a single world, or as junior members of a galactic community that's been watching us grow up. Either way, 3. Atlas forces the question that every civilization must eventually confront. Are we alone in the universe, or are we simply the last to know we're not? The mathematics gets stranger when you dig deeper. 3. Atlas moves at 61 kilometers per second relative to the Sun. That hyperbolic excess velocity ranks it as the fastest interstellar object ever recorded. Oumuamua crawled at 31 kilometers per second. Borisov managed 33. This thing doubles their speed while maintaining perfect trajectory alignment with planetary orbits. Speed tells stories about origin. Objects ejected from stellar systems by gravitational slingshots typically show velocities between 20 and 40 kilometers per second. Higher speeds require more extreme ejection mechanisms, stellar explosions, close encounters with massive stars, or artificial acceleration systems that don't follow natural physics. The European Space Agency confirms 3I Atlas originated from the galactic thick disk, a population of older stars with lower metallicity than our Sun. Thick disk objects orbit the galactic center on tilted paths, explaining the high vertical velocity component of 18.5 kilometers per second, measured for 3I Atlas. But thick disk chemistry doesn't explain the carbon dioxide dominance observed by every telescope pointed at this object. Laboratory analysis of meteorites from thick disk sources shows water ice abundance matching typical solar system ratios. Carbon dioxide remains a trace component, never the dominant volatile. Yet 3I Atlas burns CO2 like primary fuel while barely releasing detectable water vapor. The composition profile matches no known natural formation mechanism for comets in any stellar environment. Multiple space agencies coordinate observation campaigns beyond anything attempted for previous interstellar visitors. NASA deploys Hubble, Webb, TESS, SWIFT, SphereX, and multiple Mars assets. The European Space Agency contributes Mars Express, ExoMars Trace Gas Orbiter, and the Jupiter Icy Moons Explorer currently en route. Japan's Hayabusa missions adjust trajectories for possible 3I Atlas encounters. This level of international cooperation suggests classified intelligence about the object's true nature. Routine comets don't trigger emergency coordination between rival space programs. The public sees scientific curiosity. Behind closed doors, space agencies share data that never appears in published papers or press releases. Amateur astronomers fill crucial gaps in professional coverage. Sam Dean discovered pre-discovery observations extending back to June 5th, 2025, nearly a month before official detection. These images show 3I Atlas maintaining consistent brightness and trajectory long before solar heating should activate typical cometary processes. Natural comets remain dormant at those distances. Artificial objects might not. The discovery circumstances raise additional questions. 3. Atlas approached from Sagittarius, where galactic center star fields create maximum confusion for detection algorithms. It remained invisible until reaching 4.5 astronomical units from the Sun, closer than Jupiter's orbit. Professional survey telescopes scan those regions continuously. How did a 20-kilometer object avoid detection during final approach? Stealth technology offers one explanation. Advanced civilizations might coat reconnaissance probes with materials that absorb rather than reflect starlight. Radar absorbent surfaces, light-trapping metamaterials, temperature regulation systems that prevent infrared signatures. The technology exists in human laboratories. Billion-year-old civilizations might perfect such methods. The James Webb Space Telescope's infrared observations reveal additional anomalies. 3. Atlas maintains uniform surface temperature across its nucleus despite irregular solar heating. Most comets show temperature variations, as different faces receive sunlight during rotation. This object displays thermal homogeneity, suggesting internal heat sources or advanced thermal management systems. Spectroscopic analysis identifies carbon dioxide, water ice, carbon monoxide, and carbonyl sulfide in the coma, but the ratios don't match any known comet chemistry. The carbonyl sulfide abundance particularly puzzles researchers because this compound requires specific formation conditions, rare in natural environments, but common in industrial chemical processes. Ground-based telescopes track rotation period and orientation changes as 3. Atlas approaches perihelion. Natural comets typically show chaotic tumbling as outgassing creates uneven thrust vectors. 3. Atlas maintains stable rotation at 24-hour intervals with minimal wobble. Such stability requires either perfect mass distribution or active attitude control systems. The trajectory precision becomes more apparent with extended observation. 3. Atlas will pass Mars on October 2nd at exactly 18 million kilometers. Venus receives a flyby on November 3rd at 28 million kilometers. Jupiter gets approached on March 16th, 2026 at 54 million kilometers. Each encounter occurs at optimal range for detailed planetary surveillance without triggering defensive responses. Mathematical modeling shows the probability of such precise targeting approaches 0 for random interstellar trajectories. Natural objects follow ballistic paths determined by their ejection velocity and galactic environment. They don't execute precision flybys of multiple planets unless guided by intelligence or impossibly lucky physics. The galactic origin story supports artificial hypothesis through different reasoning. Objects from the thick disk represent an older stellar population formed when the galaxy contained fewer heavy elements. Such environments produce fewer rocky planets and less complex chemistry. The probability of advanced life emerging in thick disk regions remains lower than in younger stellar neighborhoods like our solar system's location. But older doesn't mean primitive. Civilizations that developed in the thick disk gained billion-year head starts over species like humanity. They witnessed the formation of younger stars, the evolution of galactic chemistry, the emergence of metal-rich worlds capable of supporting complex life. They might have been exploring for eons while we were still primordial soup. The timing of 3. Atlas arrival coincides with humanity's technological adolescence. We developed radio telescopes within the last century, space travel within decades, the ability to detect and analyze interstellar visitors within years. What are the odds that a natural object arrives precisely when we achieve sufficient technology to study it properly? Selection effects might explain the coincidence. Advanced civilizations could monitor developing species, timing first contact for optimal psychological and scientific impact. Too early and primitive cultures can't understand the implications. Too late and mature civilizations might pose threats requiring different diplomatic approaches. Military implications remain classified but obvious. Any technology capable of interstellar travel surpasses human capabilities by millennia. Defensive preparations become meaningless against such advantages. The Pentagon's response involves increased surveillance of the object through classified military telescopes and coordination with international partners through diplomatic rather than military channels. Congressional briefings occur behind closed doors with limited public disclosure. Representatives emerge from classified sessions visibly shaken but bound by security oaths. The few leaked comments suggest government assessment of 3 Atlas extends beyond scientific curiosity into national security implications. International law provides no framework for interstellar visitors of potentially artificial origin. The Outer Space Treaty governs human activities in space, but doesn't address contact with non-human intelligence. Diplomatic protocols assume terrestrial nations as the only relevant parties. First contact scenarios require entirely new legal structures. Religious communities prepare theological responses to confirmed extraterrestrial intelligence. Some denominations embrace cosmic neighbors as divine creations worthy of love and fellowship. Others interpret alien contact as demonic deception or apocalyptic signaling. The Vatican maintains official silence while quietly consulting with astronomers and exobiologists. Scientific conferences scheduled for early 2026 suddenly overflow with registration requests. The International Astronomical Union plans emergency sessions to address 3 Atlas findings. Academic journals clear editorial calendars to accommodate flood of submitted papers analyzing the object from every conceivable angle. Private space companies offer interceptor mission proposals despite impossible timelines. SpaceX calculates launch windows for rapid rendezvous trajectories. Blue origin suggests nuclear thermal propulsion options for high-energy intercepts. The technical challenges remain insurmountable for current human technology, but the commercial interest demonstrates confidence in the object's significance. Educational institutions redesign astronomy curricula to address interstellar visitor analysis. Students demand courses covering alien technology assessment, interstellar object detection methods, and first contact protocols. The assumption that we might encounter more such objects transforms from science fiction speculation to educational necessity. Insurance companies quietly assess liability implications for confirmed alien contact. Lloyd's of London creates actuarial models for societal disruption following disclosure of extraterrestrial intelligence, market volatility, supply chain disruptions. And psychological impacts receive quantitative risk analysis for the first time in human history. The carbon dioxide production rate, measured by SphereX, reaches 9.4 times 10 to the 26th molecules per second. That output requires substantial nucleus mass undergoing active sublimation, or represents exhaust from propulsion systems operating at high efficiency. Natural comets rarely maintain such consistent gas production over extended periods. Spectral line analysis reveals isotope ratios in the 3I Atlas coma that don't match solar system values. The carbon-12 to carbon-13 ratio indicates formation in stellar environments with different nuclear processes than our Sun experienced. This supports genuine interstellar origin, while raising questions about the specific stellar nursery that created such unusual chemistry. Radio telescopes monitor 3I Atlas for artificial signals across electromagnetic spectrum bands. The Search for Extraterrestrial Intelligence Institute coordinates global listening campaigns with unprecedented sensitivity. Results remain officially negative, but several unexplained signal detections require follow-up analysis by classified military communications. Intelligence units. Optical telescopes search for geometric structures, surface patterns, or artificial lighting on the 3I Atlas nucleus. Enhanced image processing reveals surface features inconsistent with typical cometary terrain, linear structures, geometric patterns, and reflective surfaces suggest manufacturing rather than natural accretion processes, though atmospheric distortion complicates definitive analysis. The closest approach to Mars provides the best observation opportunity before perihelion passage behind the Sun. European Mars orbiters prepare coordinated observation campaigns using high-resolution cameras designed for surface geology studies. These instruments lack the sensitivity for detailed small object analysis, but even crude data might reveal artificial structures or behaviors. Social media analysis shows growing public awareness of 3I Atlas despite limited mainstream coverage. Astronomy enthusiasts share telescope images, trajectory calculations, and speculation about artificial origin. Government social media monitoring algorithms flag discussions for potential disinformation campaigns, though most content appears genuine citizen science rather than organized influence operations. Economic markets begin factoring extraterrestrial contact probability into long-term investment strategies. Technology stocks show increased volatility as investors speculate about alien technology impacts on human innovation. Defense contractors receive increased government interest despite official denials about 3I Atlas military significance. Academic papers analyzing 3I Atlas multiply exponentially as more telescopes provide observational data. Peer review processes accelerate to accommodate public interest and scientific importance. Several prestigious journals announce special issues dedicated entirely to interstellar visitor research, suggesting institutional recognition of the object's unprecedented nature. The December observation window becomes humanity's final opportunity to resolve 3I Atlas identity, before it disappears into interstellar space forever. Unlike Oumuamua, which vanished before detailed study could occur, 3I Atlas provides months of observation time during both approach and departure phases. This represents the best chance human civilization may ever have to study a potentially artificial interstellar visitor. Amateur astronomers organize coordinated observation networks to supplement professional telescope coverage. Backyard observers with modest equipment can contribute meaningful data if properly coordinated and calibrated. Citizen science projects emerge to analyze the massive data volumes that professional astronomers cannot process alone. The psychological preparation for potential first contact accelerates across multiple sectors of society. Mental health professionals develop counseling protocols for individuals traumatized by confirmation of alien intelligence. Educational systems prepare materials explaining interstellar travel, alien technology, and humanity's new cosmic context. On July 1st, 2025, a telescope in Chile spotted what looked like a routine interstellar comet. 5 months later, ground-penetrating radar at the Arecibo Observatory. Successor facility detected metallic structures beneath the Antarctic ice sheet, positioned along the exact trajectory. 3I Atlas followed when traced backward through the solar system 14 billion years. The structures aren't natural, they're not human, and they've been waiting.